Another math topic that we are going to discuss is the scientific notation. Please complete the problem in the appendix C, which is related to this topic. Scientific notation is important in science because we can use this way to represent a large number or small numbers. Large number, for example, the mass of the Earth, yes, is really big number. Yes, we had huge number of zeros in this number. Or a small number like is the case of the mass of an electron. In case of the mass of an electron, we can see this is really a small number and with huge number of zeros. Then it's not easy to handle it if we had this amount of zeros. Even to write the number is difficult. But if we use scientific notation, we don't need to write all these zeros. And what is the scientific notation? When we write any number in scientific notation, that this number has two parts. One is on the number, what is the number? And this, which is represented by A, this is a number between 1 and 10. Then the number can be 1 and should be less than 10. Then the number can be 9.9999, but can be not 10. Yes. Then this number should be between 1, should be greater or equal than 1, but less than 10. And then this number, which is represented by A, is multiplied by any power of 10. Yes. Then the B represents the exponent for 10, and this number B can be positive or negative. If the number is in scientific notation, means if the number A is between 1 and 10 multiplied by any power of 10, if the exponent is positive, always represent a larger number or greater, or the number is greater than 1. If the number is in scientific notation and the exponent is negative, then this number is smaller than 1. Okay? It's a small number. Then always remember, if you had any number in scientific notation, positive exponent represent larger numbers or numbers greater than 1. If you had any number in scientific notation and the exponent is negative, you had a small number or the number is less than 1. And you have to be careful because in some cases you can have a number multiplied by any power of 10, but the number is not in scientific notation. And why? Because this number is not in scientific notation, because the number, yes, this part, is not between 1 and 10. Now let's review how we can convert any number from a standard notation to scientific notation. And what we need to do. Then first we need to locate the decimal point, to make the number between 1 and 10. And then we need to decide in which direction we need to move the decimal, to left or to the right. Just remember, the positive exponent corresponds to larger numbers and negative exponent corresponds to the smaller numbers of less than 1. And let's try to apply this rule. Then first we had 885. Yes, 885. Then 885. Then we need the decimal point right here. Yes, we need the decimal point here because this we need the number between 1 and 10. Now we need to check how many times we need to move the decimal place to make this number between 1 and 10. Then how many places? 1, 2. Always we will move from the point we want toward to the actual decimal point. Yes, then the actual decimal point is just at the end because it's an integer number, 885. Then we need to move 1, 2. Then we know, because this number is greater than 1, we know the exponent must be positive. But if you want another way, you will know if the exponent is positive or negative. If you move from the point you want toward the actual decimal point, you move to the right, then the exponent is positive. This is another way, but I think just if the number is greater than 1 here, sorry please, if the number is greater than mi madre. Okay, keep. Now let's see how we can convert numbers in standard notation to scientific notation. Then we need to follow 2 steps. First, we want to locate the decimal point to make the number between 1 and 10. Then let's try to see how we can do this one for the first example. Then we had 885. Then we need to locate the decimal point just here, yes, to make the number between 1 and 10. Yes, it's right here, 8 point. This is where we want the point. Then now we need to decide which direction to move the decimal, left or right. And for that, you simply need to remember the positive numbers. The positive exponents are always larger numbers and negative exponents are small numbers. Then in this case, we need to move here 1, 2 places, yes. And we know to make this number in scientific notation, we need 2 places. Because this number is larger than 1, then we know the exponent must be positive. It's larger number. The other way you can know if the exponent is positive or negative, if this is where you want the decimal point, then always you will move to the actual decimal point. In this case, it's at the end, yes, and we move from the point we want to the actual decimal points, then 1, 2 places. Then now we will write this one in scientific notation. Then we need to write the number between 1 and 10 multiplied by the power of 10. How many places? 2. Why we know 2 is positive? Because we had the number is larger than 1, is 885. Or because we move the decimal point 2 places to the right, yes, that'll be right here, to the right. Then let's try the next example and let's try to follow these 2 steps. Then where we want the decimal point to make the number between 1 and 10, we want just here. Now we move this 2 places to the actual decimal point, 1, 2. Then we know this exponent must be negative because the number is smaller than 1. But also we know because we move from the point we want to the actual decimal point 2 places to the left. This is negative. Yes. This is 2 ways you can determine if the exponent is positive or negative. Then here let's write, then this number is between 1 and 10 multiply by power of 10. 1, 2, and we know this must be negative. Then 885 equals to 8.85 10 to the power 2, and 0.081 is 8.1 10 to the power minus 2. One thing I want you to notice is if we had 3 significant digits here, we must have 3 significant digits also in scientific notation. If we had 2 significant digits in standard notation, we need 2 significant digits also in scientific notation. And let's practice this too. And here we want the number between 1 and 10. Then we need the decimal point just here. And now how many places we need to move to the actual decimal point? 1, 2. We move to the right, we know the exponent is positive. Also, is 200 is larger number. Then the exponent we know is positive. Then it's 2.2 10 to the power 2. Yes, it's 2 10 to the power 2. Now let's try the second one. Then we want here 1, 2, and we know this one is 2. Now we need to think if these two problems are the same problem, or we need to pay attention, yes, then to something. Then you see, in this case we had 1 significant digit. This is why here we must have 1 significant digit. And in this case, how many significant digits we had? 1, 2, 3. Then here we need to have, we must have 3 significant digits, but we need this number between 1 and 10. Then it's 2.00 10 to the power, and 1, 2, 2. Yes. We move to the right. Oh, the number is larger number. And in math, these two numbers are the same because we had here 200, we had 200, but in science, they are not the same. Here we had just 1 significant digit, and in this case, we had 3 significant digits. And if you measure this, if this is the results for some measurement, and in this case, the second measure is more accurate than the first measure. Let's try the third problem. Then we want the decimal point here. Yes. Then how many places we need to count? 1, 2, 3 toward to the actual decimal point. We move to the left. Yes. Then we know the exponent must be negative. But we know this number is less than 1. It's a small number. Then this is another way we know the exponent must be negative. Then here is 3 point. Here we had 2 significant digits. We need here 2 significant digits. Then it's 3.0 10 to the power 1, 2, 3 to the left. Then it's negative 3. Yes. The last one, we need to write 7 in scientific notation. The definition is any number in scientific notation must be equal to a number between 1 and 10 multiplied by any power of 10. Then 7 is between 1 and 10, yes. Now we need to multiply by power of 10. Do we need to move the decimal place to the left, to the right? The answer is no, and this is why here is 0. Yes, and we know 10 to the power 0 equals 1. The 7 equals to 7 10 to the power 0, and this is in standard notation, and this is in scientific notation. Now we know we can write this number, this huge number, the mass of the Earth, in scientific notation. We had here two significant digits because we don't have explicit decimal point here, and it will be 5.9 10 to the power 24. And we know even if we don't count, as we know this exponent must be positive because it's huge number, as it's larger number. In this case, we know the exponent of 10 in this case must be negative because we had a small number. And we had 1, 2, 3 significant digits. Then here we have 3 significant digits. If you count all these places, this corresponds to 31. Yes. Then this number in scientific notation is 9.11 or 9.11 10 to the power minus 31 kilograms. And it's easier to write the numbers in scientific notation, as are easier to handle than to write in a standard notation when we have really a larger number or really a small number. Now we will do the opposite. We want to convert any number in scientific notation to a standard notation. Then in this case, what we had to do is just we will move the decimal point to the right if the exponent is positive, and we will move the decimal point to the left if the exponent is negative. In this case, we had 6.075 10 to the power 3. And to convert this number in standard notation, because the exponent is 3 and is positive, we had to move to the right. 1, 2, 3. And this is why we had here 6,075. And check, we had 4 significant digits. We had 4 significant digits on both sides. Here we had 5.25 10 to the power minus 7. Then we need to move the decimal point 7 places to the left. Yes, I will count here. See, if we had here is 1, 2, 3, 4, 5, 6, 7. And this is why the number is 0.0000525. And one thing I want you to notice, we have 3 significant digits in scientific notation, 3 significant digits in standard notation. And let's try this too. And we want to write this number in standard notation. Then we had 1.25 10 to the power 6. If the exponent is positive, we need to move 6 places. Yes, because this is the power. We need to move 6 places to the right. And let's do this one here. We had 1. Here is the point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 to the right because the exponent is positive. And let's write the result. We had 1, 4. Then it's 1,250,000. Yes, it's 1,250,000. And this is the answer. Now, we know we had 1.25 10 to the power minus 6. And we know this number must be a small number because the exponent is negative, and the number is writing in scientific notation. And let me write this number here. 6 places to the left because the exponent is negative. Then 1, 2, 3, 4, 5, 6 here. And in some cases, some people doesn't like to write the 0 after the decimal point. And we can write this one like 0, 0, 0, 0, 0, 1, 2, 3, 4, 5. 1, 25. And in some cases, there are some students that they write the answer in this way. And it's right also. It's also right. But I prefer to write this here. The 0 there. Then this number in standard notation equals to 0.00000015. Yes. And as we expected, the number is really a small number. And here is just to to conclude that if we had a number in a standard notation and we convert this number in scientific notation, the number of significant digits must be the same, and vice versa also. The number of significant digits should be the same. And in this case we had 3000, but in this case we had one significant digit because we don't have explicit decimal point here. And if we want to write this number in scientific notation, there will be 3 10 to the power 3. One significant digit, one significant digit. In this case we had 4 significant digits, and we must write this number with 4 significant digits if we need to write the number in scientific notation. Then in this case will be 3.00 10 to the power 3. Yes, we had 1, 2, 3, 4 significant digits. Again, in math, these two numbers are the same, but in science they are not the same. And we need to write this number in standard notation. We had 3 significant digits here, and we must have 3 significant digits here. We know these zeros are not significant. Yes, it's 1, 2, 3. Here we had 2 significant digits, and we must write here. In standard notation, the number must have 2 significant digits. And here we had 2 significant digits. We know these zeros are not significant. It's 1, 2, 1, 2. And now we want to know how we can add or subtract numbers in scientific notation. And if the exponent of 10 is the same, then just we can add the number or subtract the numbers. Yes, and just we keep the same exponent. And in the first problem, we had 1.5 10 to the power 5 plus 6.19 10 to the power 5. And what to do? Just add the numbers. We need to add the numbers, and we need to keep. But something we need to pay attention is we need to follow the rule of significant digits. Yes. Then, because we are adding, here we had 1. If adding, we need to pay attention to the decimal places. We had 1 decimal place, we had 2 decimal places. The answer must have 1 decimal place. And in this case, then the correct number will be 7.7. We need to round up, yes, to 1 decimal place. Then the answer in this case will be 7.7 10 to the power 5. we add the numbers, we need to pay attention to the rule of for significant digits, and we need to keep the same exponent. Sorry. And it will be 7.7 10 to the power 5. And let's try the second one. It's the same thing. We had 2 here. Yes, we had 2 here. And we had the same exponent. Then yes, we need to add the numbers. 5, bring down the decimal point. Then we had one decimal place, 0 decimal places. And we need here 0 decimal places. And we need to round up, will be 6. Then the correct answer will be 6 10 to the power 2. Yes. It will be 6 10 to the power 2. And let's try now what happens in case of multiplication and division. And in case of multiplication and division, we multiply or divide the numerical part, the numbers, but we need to follow the rules for significant figures. And then we need to apply the rules we know for exponents. In multiplication, we add the exponent if we multiply powers with the same base, like in this case we had 10 and 10 here, yes. And in division, in case of the division, we need to subtract the exponents. At the end, we will check if the result is in scientific notation. Yes. And we multiply or divide the numbers, then we apply the rules, the properties of the powers to multiply or divide the power of 10, and then we need to check if the result is in scientific notation. Let's do that. Let's do this one. Then 3.5 times 2.1, yes, equals to 7.35. And let me write here. I will write here is we need to multiply the numbers. Yes. Let me write maybe this one. We multiply the numbers, and the same we had to do with the power of 10. Then 3.5 times 2.1 equals to 7.35. But we had two significant digits. Remember, in multiplication, we need to pay attention to the significant digits. Then the answer must have two significant digits or significant figures. And here, the correct answer is 7.4. Now, for the power of 10, because we had the same base, and we are multiplying the powers, and we need to add the exponents. Then, in this case, then we need to add 5 plus 7 equals to 12. Why? Because we are multiplying. And the correct answer is 7.4 10 to the power 12. Let's try the second one. In the second one, we are dividing, and let me write this one. We had 7.8. We divide the numbers, and also we need to divide the power of 10. And 7.8 divided by 2 equals to 3.9. But now we need to check the significant figures. We had one significant figures here. We had two significant figures here. And the answer must have 1. And we need to round up. 3.9 is about 4. Yes, we need to round up. Then the correct answer in this case will be 4. Now for the power of 10, we had subtraction. Then we had 5 minus 8. Yes. Then the answer is, for the exponent of 10 will be -3. Then the correct answer is 4 multiplied by 10 to the power -3. And this is the answer. And this is what we had there. Now we want to solve a few more problems that involve a number in scientific notation. Let's divide 3 10 to the power minus 3 divided by 6 10 to the power minus 9. And we divide the numbers first. And we need to divide the power of 10. And 3 divided by 6 equals to 0.5. And remember, if we had division, we need to subtract the exponents. 10 minus 3 minus 9. And what we had to be careful, yes, if the exponent of the denominator is negative, then what we had here is an addition. We had a addition. Then will be 10 to the power minus 3 plus 9. Yes, negative times negative is positive. And here we had 0.5 10 to the power minus 3 plus 9 is 6. Then the next thing we had to do is we need to check if the result is in scientific notation. Because the number is 0.5 is not between 1 and 10, the answer is not in scientific notation. Then we need to write the number in scientific notation. Then what to do is just write 0.5 in scientific notation. Then 0.5, what we need to do is we want the decimal place here, and we need to move the decimal place one. We need to move one decimal place, and we know this is another way we know is this is -1. This number is less than 1, as the exponent must be negative. But here is 5, sorry. Here must be 5. And then we had the other part of the problem is 10 to the power 6. Then here we had 5 minus 1 plus 6 is positive 5. And this is the answer. The other way we can solve the same thing is from here, this point, you had 0.5 10 to the power 6. Then we need 5. Then we need to move one place to the right. If we need to move one place to the right, we need to subtract. Always, if you move to the right in this kind of problems, if you move to the right, you need to subtract. Then if we write this one in scientific notation, will be 5 10 to the power 6. Because you move to the right, you need to subtract 1. Why 1? Because we moved one place. Then the final answer will be 6 minus 5. And in this kind of problem, if you move to the right, you need to subtract. If you move to the left, you need to add. You need to add the number you need to add depend on how many places you need to move the decimal point. Then you can solve the problem either this way or this way. I know the students, they prefer in this way. And the answer in this case will be 5 10 to the power 5. And let's try the other problem. We want to add 2.5 10 to the power 5 plus 2.5 10 to the power 4. Here the only problem is the power of 10s are not the same. Yes, then we cannot just add and keep the same power of 10 because they are different. The exponents are different. Then what we can do is we need to find a way to make the exponents to get the same exponents. Then what to do is we can use the properties of the exponents. Then we can rewrite 10 to the power 5 as 10 to the power 1 multiply. Let me try to write again this part. 2.5 10 to the power 1 multiplied by 10 to the power 4. 4 plus 1 is 5. Then it's just I rewrite the problem, and the reason I need to rewrite is because I want the same power. Then now 10 to the power 1 is just 10. Then what we need to do is multiply 2.5 times 10. 2.5 multiplied by 10 is 25. 10 to the power 4 plus 2.5 10 to the power 4. And now we had the same exponent, and what to do is just add the numbers together. 27.5 10 to the power 4. Then is this number in scientific notation? The answer is no. Yes, we need 2.75. Yes, because the number must be between 1 and 10. Then we need to move this. We need to move the decimal point here. And we need to move the decimal point to the left. Then we need to add 1 because we need to move 1 decimal point. And I will write here left, need to add. And we had here 2.75 10 to the power 4 plus 1. Then here we had 2.75 10 to the power 5. The next thing we need to check is the significant digits. Because we are adding, we need to focus in the decimal places. We had 1 decimal place, 1 decimal place. When we want the answer with 1 decimal place. Then here we need to round up. Then the answer should be 2.8 10 to the power 5. And this is what we had here. This is 2.8 10 to the power 5. Let's solve the last two problems. In the first problem, we want to add 3.5 10 to the power 5 plus 8.19 10 to the power 5. And in this case, there is no problem with the exponents. We had the same exponents. Just what we need to do is just add the numbers and keep the same power of 10. Then 3.5 plus 8.19 equals to 11.69 10 to the power 5. And what happened is now we need to check if the number is in scientific notation. And we need to check if the number is 11.69 10 to the power 5 is in scientific notation. And the answer is no, it's not in scientific notation. Yes, it's not. And what we need to do, we need to move decimal place, the decimal point 1 place, and we move to the left. 1 place, we need to add 1. And now we can rewrite this one like 1.169 5 plus 1. Then now we can rewrite this one like 1.16 power 6. Now this number is in scientific notation. Then now we need to take care of the significant digits. And in this case we are adding, then we need to take into account the decimal places. We had 2 decimal places, 1 decimal places when we want 1 decimal place in the answer. Then here we need to round up. Yes, and if we want to write this number with 1 decimal place, will be 1.2 10 to the power 6. And this is the answer. For the second problem, we need to do a little more work because we had multiplication on top, and then we need to divide the results. Yes, and let's try to apply what we know. Yes, if we multiply numbers in scientific notation, we know we need to multiply the numbers first times 3.81 multiplied by the power of 10 times 10 to the power minus 28. And we need to divide this one by 7.62 times 3.9 multiplied by 10 to the power minus 15 times 10 to the power 20. Now 1.3 times 3.81, we multiply these two numbers together, we have 4.953 10 to the power 15 minus 28 will be negative 13. Divide by let's do the line again, next slide. Then 7.62 times 3.9 equals to 29.718. Negative 15 plus 28 will be positive 13. Now we need to take into account the significant digits for each operation. Yes, we need to we multiply here. Yes, we multiply these two numbers, and we, in this case, because it's multiplication, we need to take into account the significant digits. We had two significant digits here, we had 3, then we want to write this number with two significant digits. Then we need to round up, and then if we round up this, we have 5.0 10 to the power. Then here is the same thing. We have 3 significant digits, 2 significant digits. We need to round up. Yes, then if we round up, and we need to write this one with 2 significant digits. This is 7, then 30. But we want to express this one with 2 significant digits. We need to write the explicit decimal point at the end of the number. Yes. Let me write again here. Yes. And then will be 10 to the power 2. 5 divided by 30 equals to 0.6. And it's this exponent minus this one, then will be here. It will be 0.1 minus 26. Now we need to write this number in scientific notation, and we had 0.16. We need to move the decimal place the decimal point 1 place, and we move to the right. And if we move to the right, we need to subtract. Yes. And will be 1.666 minus 26 minus 1. And let me write here, this will be 1.6 to the power minus 27. The last thing, we need to check if the significant digits. And we had 2 significant digits here, 2 significant digits. When we want to write this one with 2 significant digits, then we need to round up. Then the final answer will be 1.7 10 to the power minus 27. And this is what we had here. And this is all I have to discuss in this section.